previous question, we had our famous boat here, and it was being pulled by two ropes. This is, we've got 75 newtons and 100 newtons, and we actually had an angle here of 60 degrees, and we worked out that the boat travelled at 6 degrees left of centre. Now this is centre, so left of centre, if you're standing on the boat, left or port side's up there. So the boat ended up, rather than travelling along the dotted centre line, actually it would have been pulled by the ropes 6 degrees left of centre. This question here, rather than have a 60 degrees there now, which we know is 6 degrees up there, we want to work out what angle of theta, so that the boat, instead of going 6 degrees left of centre, actually travels along the dotted line. So the resultant of these two forces in these two ropes will give a net result so that the boat goes on the dotted line there. So the angle of theta is the one we've got to calculate. We've now got to think about, well, why would the boat go along here? Now, if there was no resultant J component, remember we just added the I's and added the J's. If when we add the J's together, we get 0, that means that the boat is not going to go either below the dotted line or above the dotted line. And the net result will be just the sum of the two I components. Now that's what we want. We want to get it such that when we add the two J components, we get 0. And that'll give us a net J, so it won't meander off the dotted line there. So let's go back to what we did before, and we've got, we'll resolve each of the forces. So R1 is equal to the absolute value of R1 cos of theta I plus the absolute value of R2 sine of theta J. So I've resolved this R1 into its I and J components. We don't know what theta is. We can substitute in for R1, that's 75. Okay, so I've resolved R1 into I and J components. We can likewise do for R2. So resolve it into its, now it'll be, well, let's just write down the absolute value of R2 cos of 30 degrees I. Okay, I've made a mistake here. It'll be sine of 30 degrees J. Now, remember we said that when we resolve R2, we're going to get a I component and my J component. So this is my J component coming down. Now, because it's coming down, that means that this part here must be a minus. All right, so it's going to, the net result, well, the J component of this force is going to be in the negative J direction. So that one must be a negative. So that's something you should be careful about. R2 is 100 cos 30 degrees I minus 100 sine 30 degrees J. Now, if we just solely want to know what the value of theta must be, we don't need to worry about what the I component is. These two, when we add them together, are going to get a net result going along the dotted line. So we could add those two together to get what the net result is. What's critical though is that the J components, when we add the two together, will cancel each other out. So if we add the J to that J, we're going to actually get 0. Another way of looking at that is just the absolute value of that and the absolute value of that have got to be equal to each other. So for the boat to travel on the centre, the J components are equal. So we're just talking about the absolute value of the J component. So 75 sine theta is equal to 100 sine 30. Now, what have we got? We've got sine theta, we're trying to work out theta, so sine of theta is equal to, now we know sine from our small triangle, sine of 30 is a half, so that's equal to 50. So to bring the 75 over the other side, it'll become a divide. So that 75 is connected by a multiply. The opposite multiply when you bring it over the other is divide. So that's equal to 2/3. So therefore theta is the angle whose sine is 2/3. Now that's on your calculator. Shift sine will give you sine to the -1, or it's inverse sine 2/3, and we get theta is equal to 41.8 degrees. So in other words, if we made that rope there pulling at 41.8 degrees, then the boat will travel right along the centre line.